Our fifth unit is to do with radical and rational functions. And you already know a lot about radical functions. You've graphed a few of those. Remember, that's the root of x, and if you remember, that graph looks something like this. We'll talk a little bit about that, but there's also an easier way to graph that now. Okay, quick review before we begin. The domain and range. Remember, domain is possible x values. When you see a line, the domain is always negative infinity to infinity, and so is the range. Okay, just a quick comment. Your textbook will probably say x is a real number and y is a real number. This means is an element of, and then this is a symbol for real numbers. Okay, I don't care which way you use. In fact, interval notation, this one is probably more useful. But you should be able to read the other one because that's the way it usually shows up in your textbook. Okay, domain for a parabola, negative infinity to infinity. The range, well, here's our lowest point. It looks like -3, so -3 to infinity. Okay, quick review on domain and range. Why do we need to know that? Well, let's get into some radical graphs. So you already know this graph. As I mentioned earlier, it's something like this, and you had memorized a few of those points. Let's look at it a little bit more closely, because what the root of x is, what this graph actually is taking this graph and applying a radical symbol to it. Okay, so let's look at that closely. Y equals x. This is the graph of a straight line. Whatever x is, that's what y is. Okay, and then we'll graph that right away in the graph below. So this is just a straight line without even looking at too many of the points. You know, it's the graph that looks something like this. Okay? And what we want to do is take a look at what happens when you take the root of x. Well, a couple things to note. First of all, if we take the root of -4, that doesn't exist. So the graph does not exist where the x values are negative. Okay, but then at 0, we have a value. So let's put that here. At 0, the root of 0 is still 0. What is the root of 1/9? The root of 1/9 is 1/3. The root of 1/4 is a half. And the root of 1 is 1. The root of 2, root 2, the root of 4, 2. So these are the points that you had already memorized. Where are we here? 4, 2, right there. Those are the points that you had learned. Okay, but a couple of things to notice. Look what happened here. The graph of the green line, y equals x, is actually below the radical. The root between 0 and 1 is actually greater than the value of x. Well, what happens after 1? Well, the root is suddenly less than the value of y equals x. We're going to use that to graph other graphs. Okay? So, very quickly, what is the domain of the original graph? Well, the domain is negative infinity to infinity, and the range is the same. What is the domain of the radical? Well, it's 0 to infinity, and the range is 0 to infinity. Okay, so let's use this information to graph a radical. A radical has the form the root of some graph f of x. So we're going to graph f of x and then take the root of it. That's how we're going to do this. Okay, a couple of things to note. 0 and 1, if they were on f of x, they will also be on the root of f of x. All right, these are called invariant points. So if f of x is 1, the root of f of x is also 1. Okay, same with 0. This is the other thing that I just pointed out, where the graph of f of x lies between 1 and the x-axis. So that's between 0 and 1. The graph of the root of f of x lies above the graph. Okay, so if you notice that, we're talking about between 0 and 1. We're looking at right in this area. Okay, what has happened there? Well, the original graph, the green one, when we take the root of it, it actually goes above the green line. Okay, and where the graph lies above y equals 1, the graph of f of x lies below the graph. Alright, and where the graph f of x is below x-axis, below the x-axis we mean negative, the root graph does not exist. Okay, so let's try a couple of these. So here is our original graph, f of x. We're supposed to take the root of it. Okay, well first of all, where is the graph 0 and 1? So we're going to do this bullet first. Where is the graph 0? Here. Where is it 1? Here. Okay, and when I say where is it 1, I'm referring to where is the y value 1. Then the next graph says where the original graph is between 0 and 1. So here is between 0 and 1. We're supposed to draw the graph above that. And where it's where it's greater than 1, so this part of the graph, we're supposed to draw it below. Now, what I would do is I would go over here and say, look at right here, y is 4. What is the root of 4? It's 2. So I know that I can take that point. And now let's connect those dots. So it looks something like this. Okay, maybe this was a little bit too exaggerated. It looks something like that. Okay. Let's try the next one. Here is f of x, and we're supposed to take the root of it. Start with where is it 0? Here. Where is it 1? Here. And then I'm going to always look for another point that I know the root of. Again, I see 4. The root of 4 is 2, so I know I'm going to have a point right here. Okay? Just to be clear, right here, f of x equals 4. And when I take the root of f of x, I get 2. Alright, and that should be enough to graph. If I connect these dots, go above there and below here. Okay? Let's state the domain and range for the new graph. Well, the domain is negative infinity all the way up to 4 for this one. The range is 0 to infinity. Okay, the domain here from negative 1 to infinity, and the range from 0 to infinity. Alright, so now a couple of different looking graphs, but we're going to follow the same principles. Oh, hang on for a sec there. Okay, so now I got it plugged in. So take a look at this graph. Let's follow the same principles. This is the graph of f of x, and we're going to take the root of it. So first of all, where is the graph 0? Here and here, right? Because f of x is 0, the root of f of x is 0. Then let's go where it's 1. Here and here. Okay, and then what I usually do again is look for another value that I know the root of. Here is 4, right? That's f of x is 4, so the root of f of x would be 2. So between 0 and 1 I should be going. Now careful here, you don't want to go like this. You don't want to go like that. What's wrong with that? Well, that's no longer a function. Okay, so what we want to try to do is stay above the line, but not go outside of a function. And then I'll connect here, and then I want to come something like that. Alright, so very quickly, what is my domain? Negative 1 to 3, and what is the range? 0 to 2. By the way, no graph exists down here because you can't take the root of a negative number. Okay, that graph's a little bit ugly. I feel like it shouldn't be quite so crooked. Let's try to clean it up a little bit. So, maybe a little bit better. Okay, next one. Here's f of x. Step 1, where is this graph 0? Where is it 1? Well, it's 0 here, it's 1 nowhere. And then you think, well, okay, between 0 and 1 I'm supposed to do something, and where it's greater than 1 I'm supposed to do something, but there's nothing going on here. So this is actually the end of the graph. That's all we can do. All of this you can't take the root of. Okay? So what is my domain? My domain is just 2. What is the range? Just 0. Okay? Next one. This one's a little bit of an odd one. Okay, so we're going to go to look at this graph. Where is f of x equal to 0? Here and here. Where is it equal to 1? Here and here. And then I can go to where is it 4? So 4 would be here, so the root 4 is 2 right there. 4 is here, so the root of 4 would be 2 right there. Okay, and now between 0 and 1, between this graph right here, I'm supposed to go above this line. So if you think about above the line, I'm going to be up here. Then I'm below the line, and so I'm going to be something like this. Over here, same idea. Okay, and again, negative, can't take the root of a negative, so nothing's going on down here. Okay, how do you write domain when it's in two pieces like that? It's negative infinity to negative 1, and 3 to infinity. What's the range? Well, even though there are two pieces, you look for the lowest value, which is 0, and then it goes up to infinity. Alright, last one of the parabolas. Again, here's f of x. Take the root of each of the values that you know. Well, you know that at 0, the root of 0 is 0. You know that at 1, the root of 1 is 1. And you know at 4, the root of 4 is 2. Okay, so just to be clear, here is the value of f of x. It's 4. Same with up here. And I'm taking the root of those. And now I want to connect the dots. Again, between 0 and 1, I'm above the line. So I should be like this. And then it's a little bit unclear here what the shape of this should be. Right? We don't really know, is this arrow going to be going more like this or more like this? So I would try to end it as soon as possible. Be careful, if you don't see an arrow here, you shouldn't have an arrow there. Okay? I would say don't extend it too far because we're not really sure about the shape after that. Okay, so here we'll do the same thing. Something like that. In this case, the domain is negative infinity to infinity, and the range is from 0 to infinity. Alright, last one like this, a cubic function. Alright, by the way, just a quick note here. If you get a test question now, let's say you had one of these earlier in the year. Let's say it's, I don't know, negative 2x minus 1, and you're supposed to take the root of it. You could graph this using transformations, or you could start by saying, hey, I know what this line looks like. Graph that line and then just take the root of it. Okay, that's something to keep in mind if you're graphing radical functions. Okay, let's take a look at this one. Where is it 0? Here, here, here. Where is it 1? Here, here, here. And then I look, well, where is it 4? Here it's 4, so the root is 2. What's the value right here for this peak? Well, here f of x is 3. I know the root of 3 is approximately 1.6, I think. So this is going to end up being, somewhere around here. I wouldn't put 1.6, I would say let's call that root 3. Okay, and then if I want to connect these dots, Ooh, that's crooked. So it looks something like this, something like this. And then over here, above the line, below the line. Okay, and the domain, well, this is a little bit ugly. I don't really know what this value is here, but let's say it's, I don't know, negative 1.6, and then it goes up to approximately 1.6, and then starts again at 1, 2, 3, 4, I don't know, should we call that 4.5? And all the way to infinity. So that's graphing radicals. One more thing I wanted to highlight for you is this question here. First of all, using graphing technology, this will not be an exam question. It will not be a test question because you don't get graphing technology on a test. So I don't think this would ever be a test question. Now, could you solve this? Well, you could. If I wanted to solve this, I could graph y equals the root of 2x minus 1, and I could graph y equals x minus 4, put them both on the graph, and let's just make this up, it would look something like this. And the solution would be, well, where do they cross? Now, this is important for you to understand. If they want to know what the solution is, right now you're looking at that and going, oh, that's a point. It's a value of xy. But it's not. Look at the original equation. There is no y here. So if they're looking for the solution, we're looking for the x value that makes that equation true. So if you were given this question, your answer should be x equals something, whatever this value is. That's what you would put here. I've seen a question like that where they give you a graph and they say, using the graph, state the solution. Please state this, just the x value. Use x value to state the solution. Okay, so that would be the only thing I think you would need to know how to do if you were given a question like that. I think it would be given as a graph and you would have to find the answer of where they intersect. Okay, but if you were given this question, I don't know, maybe some sort of a entry quiz to get into some faculty, maybe a math contest, how would you answer it? Well, you could do this algebraically. Okay, if you remember how to solve that algebraically. How do you do that? Well, you would take the square of both sides. So you get 2x minus 1, and then you would get x squared minus 8x plus 16, and then you would solve. Okay, I do not think that will be on your test, will not be on your final exam. So, homework. Please do page 89, numbers 5, 6, 8, 10, 11, 12, 14. You can also try number 9. And a quick note about number 6, it says use graphing technology. Try to do by hand, but don't worry if you can't. It's just good practice. All right? Good luck with that.